In the previous video, I opened up a non-working Vaxstation 3100 that I acquired as a long-term project, hoping that there may be some life left in the old machine. After cleaning up the corrosion and 35 years worth of embedded dust bunnies, I started by testing the power supply to ensure that I didn't blow up the system before I got started. The only issue I found with the power supply is on pin 7. Although it is supposed to provide positive 3.5 to 5.25 volts, I measured 133 millivolts. If anyone out there is familiar with the H7821-00 power supply in the 3100, I am wondering if this may be expected when not under load, or if this is an issue. Likewise, if anyone has any links to a schematic for the power supply, it would be very appreciated. I have traced the feed to pin 7 coming from this card soldered onto the main power supply PCB, but I am not quite ready to desolder it yet from the main PCB for analysis. After connecting up a minimal configuration of the main board and a memory board, I was able to power it on and see signs of life from the status LEDs on the back of the case. However, for further testing, I need to hook up a serial device to my PC so that I can get the results of the power on self-test. Since I don't have an RJ12 cable with MMJ ends, nor a VT220 serial console, I needed to make do with what I have. First step was to identify the DEC serial pinout. Thankfully, the serial pinout is well documented, including right here on Wikipedia. So I took an RJ12 cable, clipped the center latch so that it would fit into the MMJ plug with the offset latch. I cut the data cable in half and soldered breadboard wire to the stranded ends so that I could build a breadboard breakout. And I wired the transmit and the ground through to the DB9. Since I don't have a sync on green compatible monitor, I need to enable the self-test output to go to the printer serial port. To do this, switch S3, which is located between the serial port and the status LEDs, must be flipped to the up position. I first attempted to use an FTDI serial to USB adapter. This did not work at all, and I saw no terminal output. Although there are solutions using the FTDI IC, along with level shifters to convert RS-232 levels to TTL, this particular breakout board does not have any such support, and I will need to acquire a serial to USB adapter that will support RS-232 levels. Before proceeding with any other options and making any purchases, I wanted to verify the expected pinouts. So I connected my oscilloscope to the breakout board so that I could observe any signaling. After powering on again, I could see the transmit pin drive RS-232 voltage levels. And as the self-test progressed, I could definitely see data traffic. So next step was to purchase a USB to 9-pin serial adapter. However, before I placed my order, I was able to locate a very old adapter in a junk box that I haven't looked through in 10 years. And lo and behold, I found the adapter I used to use for my home Cisco lab back in the day. For testing purposes, I am only concerned with capturing the output from the Vaxstation, and I do not yet need to send any commands. I need to wire the Vaxstation's transmit pin to the receive pin on the PC side. Likewise, I need to connect the transmit ground to the DB29 ground pin. For the next phase of testing, I will wire up the Vaxstation receive pin and tie the two ground pins together. Here you can see my wiring from pins 2 and 3 of the RJ12 data cable through the breadboard breakout and directly to pins 2 and 5 of the DB9 adapter. I wasn't sure that I'd have any luck on my Windows machine. When I plugged in the DB9 to USB adapter to my PC, the device manager stated that it was obsolete over a decade ago. Trying my homebrew wiring job and powering up, voila, I'm getting self-test output. A lot of these failures are to be expected, as I have no serial card, disk, battery for the time of day clock, or Ethernet termination. Also, I have not yet wired up receive data lines, so I cannot run any self-tests. I need to note that the self-test is sporadic. It doesn't always look this good. Many times when I power it back on after the first power on, it fails to make it this far, and I need to leave it powered off for a significant period. Although I don't have a solid understanding of the problem that remains, I am left wondering if I may have capacitor issues, either on the main board or in the power supply. I'm leaving the 3100 in this state for tonight, and I will wire up the receive pin and see what progress I can make later. Thanks for watching, and if you have any thoughts, please leave them in the comments.